So I took a picture of the calculator, and what we've done in the past is learning that the log of a base will cancel an exponential base, in essence, clearing everything out. So the same thing happens if you start with a log base 5 and you want to get rid of it, you use the inverse function, which is exponential. So what happens, and I always told you guys, well, 4 weeks ago, to watch your levels. And so I wanted to show you this on the calculator, that what this is 5, and the exponent of that is log base 5 of 3. And that's a cancel move. All right, so that's pretty much all this first part is on page 18. So we have two logarithm equations equaling each other, and we just have to solve. So it's first couple of questions are really simple since you have matching logs, log base 5 and log base 5. This is no problem. We do what's called exponentiate. So 5 to the log base 5 of 5x plus 9 equals that. That is simply the cancel move, so that all we're left with is the linear equation 5x plus 9 equals 6x. And as always, once we get there, you're on your own. For number 2, same thing. We have log base 2 and log base 2, which means we simply exponentiate with a base 2, cancel move, leaving you with 1 minus 4n equals 2n plus 43. You guys can go from there. Pretty simple process, honestly. 3, same thing as 1 and 2. You guys can handle that. So number 4. Now number 4, you're going to have to remember your log rules. So a couple of things. Again, log without a base is understood to be log base 10. But if you notice in the instructions that I seem to have cut off, you need to condense each logarithm. And that is something we did almost a month ago. So if you've forgotten it, no big deal. I'm about to remind you. Boo! Clear all that. Clear all that. All right, here we go. Plus is times. So we're condensing these two log statements into one. And so log of y plus 5 plus log of 4 means log of 4 times y plus 5 equals log 72. Now we have what we had on case 1, 2, and 3, where we have two separate logs separated by an equal sign, and they've been condensed. So all I have to do is exponentiate, and solve 4y plus 20 equals 72. I think this is the next page. I don't know, but number 5. So more of the same, where we have to actually condense our logarithm. So remember what we do with this 3. This 3 becomes an exponent on that 4. So the next line is log base 7 of 4 to the third power equals log base 7 of 4a minus 8. We exponentiate, and 64 equals 4a minus 8. All right, not too bad. See if I can get this thing to move over. Yay. Condensing logarithms. Again, we have a minus sign. Subtraction means division when you condense. So we have log base 4 of 68 over 4 is equal to log base 4 of 3n plus 11. Sorry, I'm taking up so much space. It's hard to write with a stylus. Exponentiate, exponentiate. 4 into 68 goes 17 times, so 17 equals 3n plus 11. And I trust you guys can solve those. What do we have next? Okay, so coefficient becomes a power. Nothing over here to do. So log base 6 of 25 to the 1/2 power is equal to log base 6 of 23 minus 4w. Y'all can write smaller than me, so please do. Exponentiate, exponentiate. 5 equals 23 minus 4w. Okay, last one, number 8. Nothing to condense over here. Got to condense all of that. So we've got two things to condense. We've got a coefficient of 2 that only goes to the 6. We have a subtraction sign, which means division. So I'm going to see if we can handle this pretty easily. Log base 3 of 2p minus 5 equals. All right, condensing means 1 log, and 6 to the second minus is divide by 4. So 6 squared over 4. Try to take fewer steps. Exponentiate, exponentiate, 2p minus 5 equals 36 over 4 is 9. Yay, us. All right. Little bit more. Okay, so we look at the directions, condense and isolate the logarithm, write the equation exponential form, solve and check for extraneous solutions. We don't have calculators. We don't have to check for extraneous. We'll just get as far as we can, like I said earlier, and just go where we can. Now, we only have a log on one side, and that's actually kind of cool. It's still exponentiate, so you have to exponentiate with a 2 here to cancel the log, but you exponentiate over here, and so what that is x minus 4 equals 2 to the 6th power. Now, if you don't know what 2 to the 6th power is, you can use your phones for that one. But 2 to the 6th power is 64. Not too bad, okay? But always, always, always condense and isolate. Nothing to condense, but we do have to isolate. This 7 needs to come over here. All right, so I add 7 to both sides. I have log base 3, 4x plus 8 is equal to, it's been a while, 4. All right, exponentiate 3, exponentiate to balance, 4x plus 8. And just know when I write the number 81 down, that's what 3 to the 4th power is. You can check my work if you need to, which would probably be a good idea. All right, good stuff. Next. Number 13, nothing to isolate, but we do need to condense. Condense. There we go. Need to erase. All right, so plus means times. Log of 2x times x minus 5 is equal to 2. Base 10. Base 10. Oh, this is going to be fun. I hope I don't need more room. I can always extend the page. Oh. Let's see what happens. 2x squared. Oh, y'all know what's about to happen. Minus 10x equals 100. And y'all can say it with me at home. Because we have quadratic, move everything to one side of the equal sign. and solve. Factor out of 2, x squared minus 5x minus 50 equals 0. And if you can't factor by now, well, I don't even want to talk bad about you, but know that I will say bad things behind your back. And I hope I did that right if I'm talking all this trash. Let's see. X squared minus 5x minus 50 plus 5 minus 10 gets me a minus 50 on the outside. Minus 10 plus 5 gets me a minus 5 inside. And our solutions that we do not have to check for extraneous are 10 and negative 5. Now, you can mentally check for extraneous and know that negative 5 won't work because you can't take the log when you plug it in here or here. You can't log a negative number. So our only true solution is 10. Luckily, you guys can pause this. So if you want to pause it because I'm going to erase all that work that I did. And you can rewind and slow down and make me sound funny, which I'm sure most of you are doing because you're rude. Okay. Condense log x squared divided by 4 equals 2. Yes? Yes. All right. 10 x squared over 4 equals 100. Even though this is quadratic, since there's no middle term, we can just say that x squared equals 400. So x equals plus minus 20. And more than likely, yes, the negative 20 would not work. So it's just x equals 20 because the square root. 2 more questions and I'm done with my first ever YouTube lesson. Okay, plus times log base 6 of x plus 9 times x. Yeah, it's ugly. I know that bothers y'all, but I don't care. 6 exponentiate. I'll fix it right here. X times x plus 9 equals 36. And just start cleaning it up. X squared plus 9x. I'm going to go ahead and move the 36 over. Y'all know how I do this. Minus 36 equals 0. I need a 9 in the middle and a negative 36. So that's going to be x plus 12. X minus 3 equals 0. X equals negative 12. Doesn't work. X equals 3. Does work. It's not that because it's negative it doesn't work. It's because when you plug the negative 12 back in here, you're taking the log of a negative number. So don't be fooled that a negative answer always means it's no solution or it's extraneous. It just means that we have to check to see if we're valid. And since we know negative 12 isn't valid, we can go ahead and cross it out. Okay, last one. Log add is times. I'm going to do it clean this time. X parentheses x minus 3 equals 1 to the 10 power, 10 power. X times x minus 3 equals 10. X squared minus 3x minus 10 equals 0. X minus 5, x plus 2. Negative 5 doesn't work. I just glanced up at the top and could see that my negative 5 wouldn't work. Or I'm sorry, that negative 2 wouldn't work. X equals 5, that's a good one. X equals negative 2 is bad because it kills logarithms. Okay, I think that's it. I told you at the end of the video I'd tell you what your homework is. I want you guys to do